What's up, my people? In this video, we will be adding and subtracting radicals. And the main thing to remember is number one, that you can't add or subtract radicals that are not the same under the radical. Also, you want to always break them down to the simplest form. So, for example, you wouldn't be able to combine those because those are not the same term or not the same variable, but you can do this one because these are the same. With that being said, these cannot be added together because this and that are not the same, okay? But I can do because these are the same. Okay, and up here, just like you would do 2 plus 3, you would say 5, and then whatever's behind, you will put there. Same thing happens here. 3 plus 4 is 7, and whatever's behind goes still back there. Okay? So, with that being said, let's go up here to some of these questions. This is the first one. Well, I have 1 square root of 5 right here, plus 1 more square root of 5 right here, plus 1 more square root of 5 right here, which means I have 3 square roots of 5. And that is your final answer. Okay? Let's go over here. Let's look at this one. I have 1 square root of 2 here. I have 1 square root of 2 here, and another square root of 2 here. That is going to be 3 square roots of 2. Because there's just, how many square roots of 2 do you have? I have 3 of those. Okay? Let's look at number 3. Well, can I break down square root of 6? Nope, that's as far as it goes. So square root of 6 stays the same. And then I have a square root of 5 here, plus a square root of 5 there. Gives me 2 square roots of 5 and 1 square root of 6. I can't combine the two because one has a square root of 5, which is like saying x, and then the other one has a square root of 6, which is like saying a different variable. Okay, let's go to the next one. As a matter of fact, pause the video right now and try this one on your own. Now that you've had the opportunity to try it, let's see what you came up with. You should have had 1 square root of 3 here, plus another square root of 3. Means I have 2 square roots of 3, plus 1 square root of 2. Now, you don't have to put the 1 here, but you can. It doesn't matter. Okay? So this can easily be written as 2 square root of 3 plus square root 2 also. You don't have to have the 1. All right. Let's get into this a little bit more, a little bit more challenging ones. All right. So now we need to break down each one of these. You want to get it to its simplest form before you start trying to add or subtract anything. All right. So let's break down 10 and see if 10 can get broken down. 10 breaks down into 2 and 5. Those are 2 prime numbers, which means they can't be broken down. So anytime we see the square root of 10, it's already at its simplest form. So this is just negative 2 square root 10. Nothing happened. Now let's talk about 2 square root of 75. Let's break down this 75 to 25 and 3. 3 is prime. The square root of 25 is 5. Put that up this way because that's going to get multiplied. So now we're left with 5 times 2 is 10. And I have a square root of 3 still under there because this 3 didn't come out. And then let's do the last one. Let's go ahead and try to break down this 10, 5, and 2. Oh, we found that out earlier. It can't be broken down. So this stays 5 square root 10. Now we got to combine all the ones that are the same, which means we can combine this one and that one because they both have square roots of 10. So my final answer for this question is going to be 10 square root of 3, and then negative 2 plus 5 is a positive 3 square root of 10. And then again, it also doesn't matter which one you write first. You could have had 3 square root 10 plus 10 square root 3. It doesn't matter which order, okay? Okay, let's go ahead and do number 6. Okay, let's break this down. 63. What times what makes 63? That's 7 times 9. 7 is prime, that we can do with that one. But 9, the square root of 9 is 3 that comes out. So this breaks down to negative 3. And then since the 7 didn't come out, it stays under. Okay? And then we go here. I don't want to miss that negative there. Okay, now let's go ahead and break down the 7. Oh, we can't break down 7 because 7 is prime. So this still stays negative 3 square root 7. Okay? Now let's break down this 50. 50 is 25 times 2. 2 is prime. And then the square root, the square root of 25 is 5. So this term, 2 square root of 50, turns into 10 square root of 2. Now we have to combine our like terms, which is this one and that one. So that becomes negative 6 square root of 7 plus 10 square root 2. Or you can write it 10 square root 2 minus 6 square root 7. Okay? Let's move on to a little bit more challenging ones. All right. Let's take a look at what we're looking at here. All right, 8 is 4 times 2. 2 is prime. The square root of 4 is 2. So this turns into 4 square root 2 because that 2 stays under the square root. Next, we got to break down 200. And when you're doing these, if you can think of them, it's the easiest way is to break them down using perfect squares that you know of. Like, for example, for 200, I could use 20 times 10. That's going to make me do more work. So I'm not going to use 20 and 10. I am going to use 2 and 100. 2 is prime. Square root of 100 is 10. So this is equal to 50 because 5 times 10. And then under the square root stays square root of 2. Okay? And then we got to do the 4 square root of 150. Let's break down 150. Well, 150, first thing that comes to my mind is 15 times 10. And this 15 breaks down to 3 and 5. 10 breaks down to 2 and 5. And remember from the previous video, simplifying radicals, if you have 2 of them, that number comes out. And 3 and 2 doesn't have a pair, so they got to stay in. So 4 times 5 is 20. Square root 3 And then I'm looking right here. 3 times 2, that's 6. And so we need to combine my like terms. And I have a like term right here and right there. So that's going to become 54 square root 2 plus 20 square root 6. That's the final answer. And then for number 8, let's go ahead and take a look at this one. Let's break it down. As a matter of fact, go ahead and pause the video right now and you try this. Go ahead and give it a shot. Okay, now that you have the opportunity to give it a shot, let's see what you came up with. And so 72 is 9 and 8. That's the first thing that comes to my head. Square root of 9 is 3. I take that out. Now I'm going to break down this 8 into 2 and 4. Oh, square root of 4. I know that's a perfect square. That's 2. I'm going to take that out. So now I got 3 times 3 is 9 times 2 is 18. And then this square root of 2 stays under. Okay? Now, in the negative 4 square root 50, let's break down 50. I could do 5 and 10, yes. But I'm going to do 25 and 2. 2 is prime. And 25 is a perfect square. And the square root of 25 is 5. So now I got to multiply those two. Negative 4 times 5 is negative 20. Square root of 2. Okay. And the last part of this, 50, is going to, I'm going to show you that you could have done, let's say we did do 10 and 5. 5 is prime, and we ended up with 5 and 2. See how there's 2 5s and we took one out anyway, and then there was a 2 left over? That's the same thing that happened in the purple section. So it doesn't matter which one you see first. It just makes a little bit less work when you happen to see the perfect squares, okay? 5 times 5 is 25. And I'm left with square root of 2. All of these have square root 2s, so we can combine them all. So 18 minus 20 is negative 2 square root of 2 plus 25 square root of 2. Negative 2 plus 25 is equal to 23 square root of 2. That is the final answer. All right, that brings us to the end of our notes. If you have any questions, see me in class. Have a good day.